proving trig identities can be a little bit challenging, but when you're proving trig identities, the trick is to simplify things into sine and cosine, and then if need be, switch them back in between tangent, cotangent, etc. And the reason being is because you can sometimes simplify things when you're in sine and cosine, things will cancel out, etc. So let's start with kind of a simple one to kind of get your feet wet here. Your goal is to get the left side equal to the right side. So let's say that I've got 1 over cosine equals tangent over sine. So when I'm looking at this, okay, so again, the trick is to change everything into sine and cosine. Well, tangent is realistically sine over cosine. So I'm going to write tangent as sine theta over cosine theta. And realistically, when I'm dividing by, a sine, because this would be a big fraction here, if I've got 2 division bars, that's really the same thing as multiplying by the reciprocal. So I have 1 over cosine theta equals sine theta over cosine theta times 1 over sine. Okay, and again, that's because I have 2 different fractions there, so I'm really multiplying by the reciprocal on that lower sine theta. Well, looking at this, I can cancel out the sines there. Well, now I'm left with 1 over cosine of theta equals 1 over cosine of theta. I just verified that the left side equaled the right side. And that was because I changed everything into sine and cosine to see things cancel. Now, it does get a little bit harder, and sometimes you have to use your Pythagorean identities or any other kind of combinations that are on that cheat sheet that I gave you. So 1 minus cosine of theta equals, and that's cosine squared of theta, equals sine theta, cosine theta, ooh, sorry, kind of got that mumbled in there, and tangent theta. All right, so again, you can work with both sides. Generally, I recommend that you kind of leave one side alone, but you can sometimes change both sides, because right now I've got a 1 minus cosine squared of theta. It's going to be kind of hard to prove that you have a square of something unless you have the 1 wasn't there. So 1 minus cosine squared of theta using your cheat sheet is going to be a Pythagorean identity. So that's actually going to be sine squared of theta. Now, I changed that on the left side. Now on the right side, I've got that tangent of theta. So I'm going to change that into sine and cosine. And we know that this is sine over cosine. Well, if I'm looking at this, I know right now that the cosines are going to cancel out. So now I've got sine squared of theta equals sine theta times sine theta. Well, sine times sine is sine squared. I am now checked out. Both sides, left side equals the right side. Now, let's get to a tricky one where we have fractions and we might have to factor. So this is like a combo deal here. Cosine theta over 1 plus sine theta plus 1 plus sine theta over cosine theta equals 2 secant of theta. Okay, I'm just going to tell you this now. This takes quite a few lines. On your homework, I'll at least tell you how many steps you should get in order to solve this. All right, so dealing with fractions. Fractions, I know if I'm adding fractions or subtracting fractions, that I have to have my denominator to be the same. So what I'm going to do here the left side here is going to get multiplied by cosine theta over cosine theta. Because this here was a cosine, so that had to be transferred over there. Which now means that this 1 plus sine theta has to be transferred over here to be multiplied. Erase that so you don't get confused. Okay, I'm actually going to slide this 2 secant of theta over, just so you got room, or I have room anyway. You can just write it off to the side on your paper. Okay, so now this is going to give me my fractions to be the same. So up top here, I'm going to have cosine squared of theta. I'm going to multiply in the numerator, but not in the denominator. I don't know, just kind of my thing. Cosine theta, 1 plus sine theta. All right, so basic distribution on the top. On this top, again, I am distributing on the top. I don't know, there's just something about in the denominator you don't normally want to distribute that stuff, and it's because you have to factor it out later. It's just kind of how the tricks of the trade have gone here. So if I'm doing my true distribution, I'm going to get 1 plus 2 sine of theta plus sine squared of theta. When you're doing this, technically you'd get 1 plus sine theta plus sine squared of theta. Well, sine and sine added together gives you that 2 sine theta. All right. Wow, that looks scary. It's not that bad. So if I combine now, I can add the top now. Remember when you're adding fractions, you add the numerators, but you don't add the denominators. The denominators stay the same. Well, if I have a cosine plus a sine in terms and they're both squared, cosine squared plus sine squared equals 1. So realistically, I've got 1 plus 1 plus 2 sine theta over cosine theta 1 plus sine theta. Again, what we added there was using our Pythagorean identity and adding the sine squared theta and the cosine squared of theta. Those added together equal 1, and that's where we got this number. Okay, and I didn't combine the 1 plus 2 sine theta yet, which is actually my next step. 1 plus 1 is 2. You could combine some of these steps, you could. So it may take less steps for you. Okay, now, looking at this. On the bottom there, I've got a 1 plus sine theta. And in the numerator, I've got something similar, but it's got a 2 with it. And I know that the right side has a 2. So I'm going to factor. If I factor out that 2, I'm going to be left with 1 plus 1 sine of theta over cosine theta 1 plus sine theta. Well, that works out nice because I can cancel that out now. So this is why I don't distribute on the bottom, is because normally something cancels out. All right, so I've got 2. I'm going to split this up a little bit. Over 1 cosine of theta equals 2 secant of theta. Now I know I said normally I'd switch everything into sine and cosine, but in this case I didn't, just because I wasn't going to touch the right side. Well, 1 over cosine of theta is realistically secant. So this is 2 secant of theta equals 2 secant theta. Verified. Okay, so what you're doing with verifying trig identities, you're using that cheat sheet to use Pythagorean theorem to make sure you're switching your trig ratios into sine and cosine if you don't know how to do that properly. Then from there, you're going to go through and try to use the Pythagorean identity and that kind of stuff. Simplify. You might need to add fractions or make things like terms. Combine your like terms, see if anything can cancel, factor out, and you're just reworking it algebraically in order to get something to equal the other side. I know it sounds easier said than done, but with practice, you will get better at this.